Hello and welcome everyone to another machine learning video. This video is a follow-up on the machine learning video I did about diamonds. In this one we will cover machine learning for professor salaries, and then also machine learning for National Hockey League salaries, and then we'll end it by a machine learning model for housing prices. Now in the last video I didn't do a deep dive of the code. In this video I would like to explain a little bit more about the code, and if you have any questions after that you can feel free to reach out. So let's get started. Before we have a look at the code, let's first go into the CSV file. I downloaded this data from Kaggle. You can just Google it. It's a website where you get loads of data that you can work with. In this data set, I don't know if you can hear that in the background. Some guy across us is revving his car. I don't know what he's trying to fix. In this file, we have the rank. So you get professor, associate professor, assistant professor, and associate professor. Then you get the discipline. I think it's only A and B. Then you get the years since PhD and the years of service. I found some big numbers over here, like 45 years of service. Is there maybe someone who's more than 45 years of service? Let's see. Wow, 60 years of service. Let's have a look. One guy, 60 years of service. That's a lot. Anyways, so yeah, male and female, and then their salary. The goal of this machine learning model is to predict the salary of a professor. If you give it the rank, the discipline, the years of service, the years since PhD, the years of service, and then the sex. But before we do that, when we do a machine learning model, we can't have male and female, so we'll have to change this. We also can't have A and B. We'll have to change that as well to numbers, and also we have to change this column to numbers as well. We can't have professor, associate assistant professor, and associate professor. We'll have to change that to numbers as well before we can train our model. So now this is the file that we have downloaded. Let's have a look at the take a dive into the code. Yeah, we'll have to import pandas, scikit-learn, also pickle. I don't think we're going to discuss this. This is just for saving files. In this case we may save the model after we've trained it, because if you save the model then you can just recall the model, then it won't take so much time to train the model. But if you don't do that, then it takes some time to train the model. But I don't think since the data is not that much, let's see, yeah, it's not even 400 rows, so it won't, in this case it won't take that much time to train the model every time. Okay, this is just to set the recursion limit to 10,000. This also pd.set options display max columns none. This is to display everything, because when you do a let me just show it. Let me comment out all of this. Say if we were to print the head, print df.head, not df.help, df.head without this. Say if we were to run this, this is what it would show. But in this example it's too small. I'll show you on the next one. No problem. Let me just do it now before I forget. Over here, this is a much larger data set, but if we had to say print df.head, let me just comment out the rest, and we had to run this. See, everything is printed, and this is quite a large data set, the National Hockey League salaries. But if we did not have this option enabled, or if we didn't set the to display the maximum columns, this is how it would look like when we had to print the head. See, so so I like to keep that in so that I see all the columns and all the data, but it depends. You can use it, don't have to use it, it's all up to you. Okay, now let's continue. Let me just uncomment all these. Okay. Yeah. Okay. We don't need this now. So now, what we talked about is replacing the text, the string, with numbers. So this is what we're going to do over here. We are going to create dictionaries for the rank, for the discipline, and for the sex, and then we are going to map the dictionaries to the different columns. So our rank dictionary, where it says professor, where it says prof for professor, we'll assign a 1 to it. Associate professor is a 2, and then assistant professor is a 3. And then over here what we do is we will map this dictionary to that column. So it'll go in here, it will say, oh, this is a professor, replace this with a 1. Oh, this is a assistant professor, replace it with a 3. Okay, and now after that, then we'll have our a function, and in this function, before we do anything, we'll shuffle the data. We'll shuffle our data set. We'll do this by saying df is equal to sklearn.utils.shuffle, and then we insert our data frame, and then we'll assign the features. If you can remember, features are the data that is input into the model in order to predict what we need. In this case, we need the salary, and what will go into the what are the features that will determine the salary? Well, the features is the rank, the discipline, the years of service, the years since PhD, and the sex. So it's basically every column except the values. So we'll define it as X, our features, by default. The features is a capital X, and the labels is a undercase Y. So it's every column except the salary column. So that's our features, and then our labels is just the salary column. All right. So here I'm shuffling the data again. I don't know if it's meant to be in there or not, but okay, I'm just going to leave it for now. Our test size is 10. We only want to test on 10 rows of data. So what this means is our test size first, and then we have our test size is 10. So that means that when we test our data, we'll only work on 10 instances. So, or 10 rows of data. So we have our trained data and our test data. Now our trained data is equal to all our data up to our test data. So since our test data is 10, that means that our training data will be all of this up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will train on this and test on this. But since we are shuffling our data, this will be mixed, so it won't be numerical according to the index. This might be 1, this might be 72, this might be 301, and so forth. The same goes here, but it will only test on the last 10, and it will train on the 380 odd before that. And then our testing data is the 10 that we have here. So it's the last 10 rows. Okay, then when we get to this step, this is now we are defining our classifier, our model. we can train our model through different types of algorithms. All the algorithms have been pre-written already. You don't need to go write your own algorithm. So in this one we're going to use linear regression. In the other one we are going to use I think decision tree. We're not going to use support vector machines, but I think we'll just touch on that. But you can choose which one works the best for you. Here we have support vector machine, but we're not going to use it for this one. You can do it and see if your results are better, but this one yielded the best results for me. And then also we'll calculate the R squared. Oh no, before we do that, first we fit our model with our training data, and then we test it with our testing data. And after we test it, it will give us a score, and that score is the R squared value, is the accuracy of this model. Then we want to print out the accuracy of the model, just to see how it is. And I don't know why I left this in here. I can comment this out because we won't be loading in our model because we didn't save it. In this video we're just going to train the model each time, and since it's not a lot of data, it won't take a long time. Let's say we want a accuracy of 90%. So what I wanted to do is, if the accuracy is less than 90%, then run the function again, run this function again. Only if it's more than 90%, I want the results to be displayed here. Okay. So the reason I'm doing that, I don't want an inaccurate model. I don't want the model to display data that makes a bad prediction. I want a model that makes a good prediction. The prediction and the real value is relatively close to each other, which we all would like. We don't want the model to say that the salary is 50,000 while the actual salary is 500,000. Okay, so now let's run the code and see what we get. Boom. Okay, now it's testing the accuracy. Oh, we made a hit. Okay, so it took us about almost 800 tests to get to more than 90%. If we have a look, we can see it predicted 116,000 while the salary was 124,000, which is not that far off. 137,000, 145. Here it's very close. What's this? About $100, $90 out. Not that bad. Before we go, let's just have a quick look at the this is for the professional salaries. This is now the machine learning model for the NHL salaries, the National Hockey League salaries. That one is more data. So as you can see here, it's if you know how the code works, then the model is not that hard to build, and you don't know you don't really need to know how the algorithm works. If you want to, you can, but like I said, I'm not an expert. You don't need to be an expert to build a model like this. I mean, I'm also learning all the time when I'm doing these things, and I'm just trying to learn from the guys that have experience and have done these things before and posted their material. And I'm sure I also make mistakes, and that's why I'm also posting. So the last one is I don't think we'll get time for the housing price model. This video is too long already. The machine learning model for the NHL salaries on this data set, it's a lot more, as you can see, way more. It has 154 columns and it is 600 rows. Okay, the columns are more, but the rows are not that much. It's also 600. It's not a lot of rows, so but the columns are a lot. Also, let me just uncomment this. Boom. Again, two dictionaries were created for the country and the position. There were 18 different countries and 17 different positions of the hockey players. Created dictionaries for that, to map it again. And here we're gonna map it. Okay. Most of the code is similar. I just tweaked a few things, but most of it is similar. By this one, we're going to use the decision tree regressor and not the linear regression. Linear regression, as we did in for the professor's salaries. And this one, I think it's more accurate. That's why I'm looking for a 95%. I don't know. Let's see if we get it. Let's run it and see what happens. On the 6th attempt, on the 6th test. Okay, that's pretty good. Okay, predicted it accurately. Also, what's that? 90,000 out. This one is way out. Let's run it again. What's it printing? Oh, 96%. 25,000 out. What's this? 100,000. Is this 3 million? Guy earns 3 million. Yo, okay, 100,000 out. Okay, but it's 96% accurate. If it's 100,000 out of a 3 million, then it's, what's that? Less than 10%? 5%? Less. If it's, yeah, a lot less. Okay, so yeah, I'm happy with this. Let's just check. Okay, yeah, there's a big difference. Yeah, it's exactly the same. Let's see what result kicks out if we do linear regression. And you can test these to see which one works the best. Okay, it's running. This one's taking some time to get to 95%. And it's slower as well. There won't be time for the housing prices model. Definitely won't be time for that one. But it's almost the same. It's just, yes, I did something extra, converting I converted a dictionary. I created a dictionary from two lists, which is not in the other two because the neighborhood, there was a lot of neighborhoods, and I couldn't do a dictionary. It would take a lot to do a dictionary by hand. Okay. So well, decision tree regressor was maybe the best one over there. Oh well. Okay, that's it for this video. Hope you like it. Questions, comments and concerns in the comment section. If you liked it, give it a thumbs up. If you loved it, you can share it. And so well, see you guys in the next video.